Okay, here is your mini lesson over section 3.5. And so this is going to be your guided notes for transformations. So the first thing we're going to look at real quickly is a reminder of symmetry. So you can see with symmetry, we have three types with respect to the x-axis, with respect to the y-axis, and with respect to the origin. Okay, and so remember we have the definitions. So with your x-axis, you're going to replace y with a negative y, and you're going to resimplify. Your goal is to get back what you started with, but with your y's now being negative. Okay. So you can see if you start with a point AB, then replacing y with negative y is going to give you the point A, negative B. Okay. And again, if you look like this, if we were to take this graph here and fold it along this x-axis, you can clearly see that what's on the top matches to what's on the bottom. Okay. The same is going to hold true with your y-axis, and where you're going to replace your x with a negative x, do the same exact thing. So you can see here that your point difference would be AB versus negative AB. And if you look at this graph here, if we fold along that y-axis, everything on the left matches to what's on the right. The part that gets fun is going to be your origin, where you're replacing both x and y. And then here, instead of folding your graph, you would rotate your graph. So we would go 180 degrees. So if we were to, say, put a marker up on this upper corner, if you were to rotate it your 180 degrees in, say, this direction, the question is, would you get back exactly what you started with? Well, one hint that I can give you for something like that is if you put your pen right here in the middle, you can grab your page and you could say rotate your page 180 degrees and then take a look at it. Now, is the graph that we're looking at now the exact same graph that we saw before? Well, the answer there is yes. Okay, so that is something you can do with your origin tests. Now, the other thing we have is what if I give you an input or a point, and I want to know its symmetric point to the x-axis, y-axis, and origin. Well, again, that means using your definition. The definition says whatever your original point is, in order to find your x-axis symmetry, you need to replace y with a negative y. So this means I have the point negative 7, 5. So my x-axis symmetry would be negative 7, negative 5. Okay, so I replaced my y with a negative y. Now for y-axis symmetry, it says that you need to replace x with a negative x. So here, this means I'm going to have negative of a negative 7 and then 5. Well, negative and negative is positive, so this really becomes 7, 5. Now the last thing we have is our origin, which says you replace both. So again, this would be replace x and y with their negative counterparts. So we would have negative of my negative 7 and a negative 5. Okay. Well, again, negative times negative is positive, so this is the point 7, negative 5. Okay. Alright, so now we're going to look at sketching a graph real quick. So we have the graph absolute value of x plus 2. The easiest thing that you could do for that is understand or make yourself a xy table and just choose a small collection of points. So I might look at 1 or 0, 1, and negative 1. And so you're going to have to evaluate. So here we're going to have the absolute value of 0 plus 2 is really the absolute value of 2, which gives you 2 as a result. Remember, absolute value says whatever goes in comes out positive. So now we can look at 1. So we're going to have the absolute value of 1 plus 2 makes us the absolute value of 3, which comes out as a 3. Last but not least, we have a negative 1 plus 2. Well, negative 1 plus 2 is a 1, which comes out as 1. So here we've got our 3 points, so we can go ahead and we can graph that. So here we've got the point 0, 2, so 0, 1, 2. Then we have the point 1, 3, so over 1, 1, 2, 3. And then we've got the point negative 1, 1, so negative 1, 1. And so here you can see that, I mean, clearly I have not exactly graphed my V yet. So one of the things that you might want to do is keep going. We're going to use the same idea that we used with your quadratics, okay? So here we know if we plug in a negative 2, we're going to end up with a 0. When you plug in negative 3 plus 2 is a negative 1, which comes out as a 1, and so right here we've changed our directions. And so here you can see that this is where our V occurs, and that is your absolute value. So we can go ahead and draw that line, and then draw it along the other side. Okay, so right here. Remember, your arrows on the end to signify that they go on forever. Okay. Now don't forget, when you work these in your actual class, in the 1111 class, and you're doing it in Hawks, Hawks will graph things for you. So you just need to make sure that you have selected as many coordinate points as needed. But to do it on paper, you're just going to kind of keep going until you round your V, because this is an absolute value. Now, in this instance, we've already talked about how to determine if it's a function. And so here, when we look at it, we know that, yes, it's a function. And the reason is because it passes your v-test, or your vertical line test. And then the last thing we have is determine the symmetry. Okay? So when you're looking at this, there's a couple ways you can do it. One, you can remember what your symmetry says, which is, did you have symmetry with respect to the x-axis? So x-axis says that you fold your line along the x-axis, and whatever is on the top should match the bottom. Well, in this case, that answer is no. And then y-axis symmetry says if you fold along the y-axis, whatever's on the left should completely match to the right, so this answer is no. And here we've got the origin, and so if I grab one and spin it, do we get the same thing back? And the answer there is no. And so in here you would say no symmetry. Okay? So the next thing that we need to look at is even, odd, or neither. So when we're talking about even, we are talking about functions that are symmetric to the y-axis. And so one of the ways we can do that is you can physically look at your graph visually. Otherwise, what you actually do is you do this algebraically, which is usually the fastest method. And so this says you're going to replace all x with a negative x and reevaluate. If you get back what you started with, then you have even. However, if you replace x with negative x and you resimplify or evaluate, and you'll get back the exact opposite, meaning every single sign in your problem is now changed from positive to negative or negative to positive, then you have odd. Okay? Again, if you wanted to do it graphically, you're talking about symmetry with respect to the origin. So whether you're doing it visually or algebraically is completely your choice. You just have to do whatever makes the most sense to you. So for example, we have given the following functions, determine if they are even, odd, or neither. So the first one says x to the 17th. So here, if we look at it algebraically, it says we need to look at negative x. So this is going to be negative x raised to the 17th. Well, what do we know? Any negative raised to an odd power is going to spit back the negative. So we end up with negative x to the 17th, which if you look is the exact opposite of what we started with. So this one is odd. Now the next one we have is x cubed plus 4x minus 2. So again, we can look at negative x and see what happens. So we have negative 7 times x, or negative x cubed, plus a 4 times a negative x minus 2. So here, negative x cubed, well that's a negative raised to an odd power, which is going to spit out a negative. So negative times negative gives you positive 7x cubed. Positive 4 times a negative x is a negative 4x, and then we still have this minus 2. Well, just because the first two terms changed their signs and were opposite, the last term stayed the same. So this one is neither. Okay. Now the last one we have is 1 over x squared. So again, we want to look at negative x, which is going to be 1 over my negative x squared. Well, negative x squared is going to come out as positive, so this is going to be 1 over x squared. Since this is the same as what we started with, this one is even. Okay. Alright, so the last thing we have is our actual transformations. So remember, when we're taught transformations, we have shifting, we have reflections, and we have stretch compress. So when we're talking about shifting, again, we're talking about vertically or horizontally. Vertically meaning up or down your y-axis, and horizontally meaning left or right. Okay, so your vertical is an external. It means your shift is occurring on the outside of your function, whereas horizontally is internal, meaning it's inside your parenthesis bubble. Okay. Same thing with your reflections. We have across your x-axis and we have across the y-axis. So when we're talking about across the x-axis, we're talking about a vertical reflection. Therefore, our negative is an external reflection. Whereas across the y-axis is a horizontal, meaning you're looking left to right. It also means the negative is found inside your function. Last, we have stretch compress, and again, we have vertical and horizontal. So here, when we're talking about your vertical, we're talking about multiplying that constant on the outside of our function. We also have that if you're stretching it, you're going to have your whole numbers, but compressing it means you have a fraction. Okay. Now, for stretch and compress, we completely ignore the negative sign because that negative sign deals with your reflection. So here, we're just simply looking at the number, not the sign of the number. For horizontal, notice my multiplication is done inside the function, and it is the opposite. So here, compressing horizontally means that we have the whole number, but stretching it means we have a fraction. Okay. So that is essentially what we are doing with our translations. So as a reminder, when you are doing your homework in Hawks, you need to make sure that you put in your translations in this order, where the first thing you do is your horizontal shift, and then you're going to complete any horizontal reflections or horizontal stretch and compresses. Then you're going to complete the verticals, and then you're going to do the vertical shift. Okay? So you need to make sure that you're kind of working in that order so that you don't shift your graph into the wrong place. Now, the other thing we have to make sure that we can do is you need to make sure that you can identify your base function. In other words, you're identifying the absolute bare minimum before anything's been added to it. So we have this function here that is -3, the cubed root of x minus 1. So the first thing we need to know is we need to know what the base is that you're working with. Well, in this case, we're talking about the cubed root of x. Then we need to look at how is it moving. So first, let's look at the horizontal shift. Well, horizontal shift means add or subtract inside your function. Well, we have that. So here we have a horizontal shift. The negative sign means that we are shifting to the right. And we are shifting to the right over 1 unit. So we are going to shift to the right 1 unit. Now the next thing we need to look at is any horizontal reflections we have. Well, we don't have any negatives attached directly to the x, nor do we have any constants attached to the x. So we can move on to your verticals. Well, here I have a vertical reflection. And so here we're going to vertically reflect, and we're going to reflect over the x-axis. And then we also have a stretch compress. So here we've got a whole number on the outside of my function. So remember, a whole number on the outside means that we have a vertical stretch. And this is going to be by a factor of 3. Okay. Now there is nothing else for us to do, and so that would be the transformation that has occurred. Okay. Now the second type that you may run into is wanting you to graph it. Okay. So here the first thing you need to know is you need to know what the base is that you are working with. Well, in this case we're working with the square root of x. So if we were to graph the square root of x, since we have to graph the parent, the first thing we know is that it's going to start at the point 0, 0. And then if you were to be creating a table, we would know that if you plug in a 1, the absolute or the square root of 1 is 1. So here would be the next point. And then if you plug in a 2 or a 3, you're going to get a decimal. But if you look at the square root of 4, that's going to be 2. So 1, 2, 3, 4, and then up 1, 2. And so my square root is going to kind of be looking something like this. And that is your base function. Okay, so this one here is going to be the square root of x. Now, we need to be able to also graph its transformation. So we need to look at what exactly is going on. Well, first we have this, we got to look at your horizontal. And so looking in the horizontal, I'm not shifting it over anywhere, but I am reflecting it. So I have a reflection over the y-axis because it's horizontally. Horizontal is internal. And then I'm also multiplying it by a constant. So this means that I have a horizontal, and because this is a whole number, the whole number says that I'm compressing it And I'm going to do it by a factor of 2. Okay. And then here, I'm also going to take it, and I've got a vertical shift going on. So I have a vertical shift, and I'm going up 3 because it's a plus. So the first thing that I would do is I would take my origin point, and I'm going to say, okay, let's go up 3, 1, 2, 3. And so there's that. And then I am horizontally compressing my function, okay? So, and I'm doing it by a factor of 2. So there's a couple ways that you could approach this. The easiest way that I've seen students approach it is making an XY table and saying that we know x, and then we've got our f of x, and so we need to plug things in. So first and foremost, I can look at 0. So this is going to be the absolute value of a negative 2 times 0, and then this would be plus 3, so it gives us 3 as a result. So then, because I'm reflecting it, there's a couple things that you could do. First, you could simply work with your compression and then worry about reflecting it when you're done, or you could try to do all of it at once. I would suggest working them in steps and working my horizontal compression first and then worry about reflecting it, but it's up to you. So one thing that we could do is you could say, okay, let's plug in negative 1. So here, I'm going to have the square root of a negative 2 times a negative 1 plus 3. Negative 2 times negative 1 is a positive 2. The square root of 2 is going to be a decimal. And so here we're talking about the square root of 2 being hang on one second. Okay, so we're talking about 1.4142 blah blah blah. Plus 3 means we're looking at a value being roughly 4.41. So when we talk about that, we've got negative 1. And by making this XY table, you're actually doing all of your translations at once. And so here over at negative 1, we're going to come up here 1, 2, 3, 4 and a little bit. Okay, so what you should notice about your graph is that it is shrinking towards that y-axis. Okay, you're basically squeezing it. That's what a horizontal compression is. And so then the other thing that we have to look at is, I don't know, we could use about negative 2. So here this would be the square root of negative 2 times a negative 2 plus 3. Negative 2 times negative 2 is 4. The square root of 4 is 2 plus 3 gives you 5. So here, over at negative 2, we're up 1, 2, 3, 4, and 5. Okay. So what you would notice is that your new graph would be something about like this. Okay. And in making this XY table, you've actually taken all of your reflections, your stretches, and your shifts into account all at once. Okay, so that would be the smartest or the best way that I would tell you to go ahead and do it, is to just create that XY table. The biggest thing that you want to keep in mind when you're creating that table is that you need to follow your basic rules. So for example, we know that a square root can't have negative numbers under the radical. So when I was creating my table here, I was taking that into account, that had I used +1, I would have had a negative here, which would have been imaginary. So because this -2 was under there, that's why I had to chose -1, and that's why I chose -2, was to take that negative into account. Okay. Now the last thing that you're going to have to look at is use the parent-based function given to write a new function that does the following. So we're going to reflect across the x-axis, we're going to stretch vertically by a factor of 2, and then we're going to move up 3 units. So we're going to have a g of x where we have to do all of those to x squared. So the first thing I would look at is, okay, am I shifting horizontally? Well, no, I'm not. But now I need to look at what am I doing? Well, the first thing I'm doing is I'm reflecting across the x-axis. That is an external shift. So this right here, if you remember, was where we had talked about y equaling negative f of x. Okay. Stretching vertically by a factor of 2 was where we looked at y was a f of x. Okay. And then when we're moving up, this right here is where we're looking at y was f of x plus or minus b. Moving up says that we're going to use the plus part. So here we need to put all of that together. So we have g of x is, then we've got a negative on the outside, factor of 2, and this is x squared, and then plus 3. Notice everything is being done externally. Everything was done vertically. Thus, we have written our function. Okay. So from this point, it is up to you to work those practice problems. Remember, in order to get participation credit, you need to take pictures and send me images or upload the document of you working those practice problems. And as always, if you have any questions, please make sure that you put those questions and comments in the discussion box so that they can be used at our next virtual classroom meeting. So as always, have fun, enjoy your math, and we'll see you next time.